very much appreciate your attendance today. So far, we only have a few people on the call, but I expect more will probably join as we get started. So the topic is functional safety assessment, which is one of the important aspects of functional safety relating to the design and management of functional safety systems. And just to clarify what we mean, a functional safety system is one that achieves risk reduction by some kind of automatic system that detects the presence of a hazard and then takes an executive action to mitigate the hazard. And the executive action can be something like closing a valve or starting or stopping a motor. And it's a fully automated system.
Functional safety assessment is one of several techniques that is used to confirm that the management system is working well. In some ways, it is quite similar to a quality management assessment. So it tends not to get too bogged down into the small details of exactly how every single step of the design and construction and operation of the system is going, but it tends to focus on higher level aspects, looking at, for example, the competency of the people who are responsible for the safety system, and whether the management system is in place and whether it's functioning properly. So the overall objective is to try to make sure that the safety objectives in terms of achieving risk reduction are actually being met by the functional safety system. Functional safety is covered by a series of international standards. The overall standard is IEC 61508, and that is applicable to all industries. And then for many specific industry sectors, there are standards derived from 61508. And for example, for the process industry, the relevant standard is IEC 61511. And there are a whole set of other standards, for example, for machinery safety, for medical devices, for transport safety, for nuclear, and all of these others. But the functional safety assessment requirements are relatively similar between all of these. We've talked about the importance of maintaining the risk reduction that's required by the functional safety system. Now, the thing that can stop a risk reduction from occurring is when the system experiences failures. And failures can be considered of two different types. One is random hardware failures. This is where some piece of equipment physically breaks during its expected lifetime. And the other is what we call systematic failures. Now, these are failures that are in some way built into the design or the operation of the system, which nearly always arises from some kind of human error, either at the design phase or construction or commissioning or operation phase, or even in the risk assessment, risk analysis phase. And eventually, when the stars all line up and the right kind of circumstances arise, it can lead to a failure of the system so that it can't provide the required risk reduction. Now, functional safety assessment is targeted at systematic failures. So it's one of the techniques that we have available to detect when human errors may have occurred and to try to catch them before those human errors lead to a failure of the safety instrumented system. There are several activities of this type, which I call confirmation activities, or you could call them quality assurance activities or something like that, throughout the safety management system for functional safety. And I think it's worth going through all of them briefly now, just to make sure that we're all clear on what they are, and very important to understand their differences. Because they're not interchangeable, and you can't kind of cover an absence of one of them by performing another one. Each of them is different, and each one has its own important role within the functional safety management system. So these are the four what I call confirmation activities. The first one is verification. This is different from SIL verification. This is functional safety lifecycle verification. What it means is that for each phase of the functional safety life cycle, which means each individual activity that is performed, needs to go through a verification activity. And what that means is somebody needs to review the outputs that were produced from that activity in order to confirm that the outputs are suitable for use and the outputs are basically correct given the input information that was provided and given the procedure that should be followed to produce those outputs. So for example, when you perform the HAZOP study to identify the risks at the beginning of the functional safety life cycle, after completing the HAZOP, it should be verified to confirm that basically the outcome from it is correct in terms of it matches the inputs and it's suitable for use for the rest of the safety life cycle. And the same applies to all the other phases. For example, the SIL determination study, development of the safety requirement specification, development of the preliminary design of the SIS, and so on and so on. Each phase, one by one, needs to be verified. The second one is validation. Now, validation is essentially a one-time activity where you do some tests and some inspection on the SIS after you've completed the construction and commissioning. And the purpose of validation is to confirm that the safety instrumented system that you've developed actually matches the specification. So normally you only need to do validation one time during the life cycle, although if you, after startup, do some modifications to the safety instrumented system, you usually need to revalidate, but only for those specific modifications that were made. Validation is also known as pre-startup safety review, or PSSR. It's essentially the same activity. The third one, functional safety assessment, which is the topic of our webinar today. This is a high-level review of the management system for functional safety to confirm that the overall safety objectives of the safety life cycle are being achieved. And that it should be performed at several different stages during the life cycle of the safety instrumented system, and we're going to explain that in a few moments. And then the fourth type of confirmation activity is a functional safety audit. Now, this is very similar to any other kind of audit. It's focused on procedures. So the idea is to look at a procedure such as the functional safety management plan, such as the management of change procedure, the HAZOP procedure, the configuration management procedure, and whatever else there is for the functional safety system. And each procedure needs to be audited to confirm that there is evidence that the procedure is being followed properly. So we've got these four different confirmation activities. They're all focused on minimizing the chance of human errors leading to systematic failures, but they all take a different strategy, and none of them can be skipped. So very important to make sure that the whole suite of four activities is being properly carried out. Now let's focus purely on functional safety assessment from now on. I mentioned a moment ago that it is supposed to be executed at various different stages during the functional safety life cycle. So here are those stages, and these are defined in the IEC 61511 standard for the process industry. The first stage, stage one, is after completion of the hazard and risk assessment. So that would be after you've done your HAZOP and SIL determination study. Stage two is after you prepare the first draft of the safety requirement specification. Stage three is after completing the validation, which means you've done all of your design, your construction, your commissioning, and you're basically ready to start up the process with protection provided by the safety instrumented system. But before you hit the big green button, you need to complete stage three, FSA, or which, as I mentioned a moment ago, is essentially the same as pre-startup safety review. Stage 4 is supposed to be a review that you perform after you've been operating the process for some time with the safety instrumented system in place. So that could be 6 months, 1 or 2 years later, basically to confirm that all of the operations requirements, such as operator training and maintenance and review of any incidents found, and management of change if any design changes are happening after startup, just to confirm that all of those processes are working properly. And then stage 5 is after completing any modifications to the SIS after you've started up. Now, according to IEC 61511, all of these stages are recommended, but only stages 3 and 4 are actually compulsory. However, we do strongly recommend that you perform the FSA at all of these stages, because, again, bearing in mind that the purpose of it is to minimize the chances of human errors leading to systematic failures that could eventually result in a very serious accident. So it should be a very key part of your overall process safety management. And for the amount of effort that it takes to perform an FSA properly, the benefit in terms of safety should be quite considerable. So I think it's not something that you need to feel it's too burdensome. It's relatively easy to perform if the documentation is in good shape. The standard gives very little information about how FSA should actually be performed. There's only a few small clauses describing what is supposed to be achieved, and it doesn't give any kind of detail or really very much guidance at all about how FSA can actually be done. And you'll find that every consultant who executes FSA has got their own different approach to it. But based on my observations of how various different consultants perform FSA, I tend to see that there are two main strategies for doing it. The first one is what you might call a systems-centered approach. Now, this is where you typically you go through the relevant standard, for example, IEC 61511, clause by clause for every single relevant clause, relevant to the stage that you're performing the FSA for. And you search for evidence to confirm that each clause is being complied with. So it's very much a kind of a going through, ticking boxes one by one, focused on compliance with the standard. The second approach is what I would call outcomes centered. And for me, this is where, to me, it's a more kind of human focused approach. It's where we say, well, what are we actually trying to achieve? Bearing in mind that the purpose of FSA is to confirm that the safety objectives of the safety instrumented system are being met, not to confirm that we are complying with the standard. That is not the end, that is the means to the end. And so, as you can probably tell from the way I'm explaining it, I personally prefer the second approach, which is where we focus more on what is the functional safety management system supposed to achieve? What's the outcome, the end goal of it, not so much focusing on the procedures that are meant to achieve that end. So the way I would prefer to do it is to have a checklist of what outcomes do I expect, and what are the steps that I would expect to see along the way, and can I find evidence to confirm that all of those steps and all of those outcomes are really being achieved. So both of these will typically follow a checklist approach, but the checklist looks rather different from the two approaches. Let me give you an example. Supposing we are considering the requirement that anyone who performs a task relating to the safety instrumented system must be competent for that task. So the system-centered approach would say, I see this requirement in the standard part 1, clause 5.2.2.2, and it lists out some specific competency requirements there. So I, as your FSA consultant, would say, okay, please show me evidence of compliance with this clause. That's the system-centered approach. The outcome-centered approach says, okay, I want to confirm that each person is competent. Show me some way, show me how you assess it to determine the competency of each person, and let me review that to confirm that it seems like a reasonable way, that you're not cutting corners, that you're actually genuinely confirming each person is competent. So you can see it's more of an outcome. I want to see that everyone is competent rather than I want to see that you have complied with clause 5.2.2.2. And to me, that approach may be, it certainly can be easier to comply with because it allows you to show me within the existing systems that you already have. Because especially if you're running a quality management system, such as ISO 9001, you already need to have a system within that framework to demonstrate competency. So why have another system in order to comply with the functional safety? Can't we just use the one system for both applications? And personally, I think we can, as long as it meets the requirements. So anyway, that's just an example of how the question that we would ask would be different between those two approaches. Now, let's have a look at the overall view of what it would take to achieve a functional safety assessment. So the first thing we do is we develop a procedure. xSeriCon has got quite a lot of experience of this. So we have a kind of standard procedure that we use as the default. And the first thing that we would do when going into working with a new client is to offer them our standard procedure and invite them to update and customize it according to their own needs. But in practice, it generally needs very little customization. The second thing we do is we develop a checklist of the issues that we're going to address. And I will say a lot more about how the checklist works a little bit later in this webinar today. Then our preparation is done. So the next thing we do is we start asking for evidence to show that the issues that we want to raise on the checklist are being addressed in the functional safety life cycle. So we will basically, most of it we'll be able to do by referring to documents. So we will ask for documents and specific documents where we expect to find the answers. We will work through the checklist, work through the documents in order to try to find the issues. Now, I would like to mention that this is not meant to be a review of the documents. We will not review and comment on the documents. That is not the job of FSA. That should have already been done, for example, as part of the verification activity. However, what we will do is we will search through the documents in order to find evidence to support the checks that we want to make, and we will also generally scan it to check that things generally seem to be how they should be. I mean, for example, if we find missing signatures where we don't see evidence that the document has been reviewed and approved, then we may raise that as a concern. Or if we see, for example, document numbers that don't seem to match up from one place to another, then we may raise that as a concern. It could be that it's simply a little typo of no great importance, or it might be a symptom of a problem with the document management system. So we won't let anything just pass by. We will raise issues, but we'll try to rank them in terms of importance, and always give the client the opportunity to resolve the issues before we take it too much further through the FSA. Now, the other key part of the FSA is we normally will need to have some kind of interviews or discussions with a small number of key personnel. And the main reason for this is we want to confirm that people who are responsible, especially in management roles, actually know something about functional safety. And they know that there is a functional safety management plan. They need to know what it requires of them, what their responsibilities are, and we need to be able to see evidence that they're actually following that through. So they're actually implementing the requirements of the functional safety management plan. because the management plan is not meant to be a great big thick document that just sits on the shelf and does nothing except achieves a tick in a box. It's supposed to be a living document that actively guides the team through the functional safety life cycle. So let's talk a little bit about the functional safety assessment procedure. Now, in practice, the procedure is usually provided by the assessor, himself or herself. And the reason that it's provided by the assessor and not by, for example, the engineering company or the end user, unlike, for example, the HAZOP procedure, is that normally the end user or the engineering company don't have that much experience of FSA, and they tend not to have that clear an idea of how they want to achieve it. So, and also, as I mentioned before, each assessor usually has a slightly different approach. So that's why we, as an assessor team, the first thing we'll do is provide an FSA procedure for the team's review and comment. Now, here are some of the things that need to be in the procedure. We need to say who exactly will actually execute the assessment. The reason for this is, well, partly because it is a requirement of the functional safety management that you always have to specify who exactly is responsible for each kind of safety critical task, again, so that you can confirm their competency, but also because there is an independence requirement. Actually, the standard has very few independence requirements in terms of personnel, but this is one where it does say very clearly that whoever is the lead assessor or senior assessor for FSA needs to be not involved with the parts of the project that they are assessing. So there has to be a very clear arm's length assessment, independence there. We also need to give some kind of indication of when, as in what stage of the life cycle will the assessment be done. The reason for that is we have to make sure that the team knows what preparations need to be done, at what point can we trigger the assessment. One quite common problem that we see is people asking for the assessment too early, when the design is not mature enough and the documents are not really ready. And that can be quite difficult because then we end up raising a huge number of issues relating to missing evidence, which then all have to be laboriously closed out one by one. Whereas if we had just waited a few more weeks until the documents were actually ready, then all of those issues would not arise. The third one is almost the same as what I just said. What are the criteria for determining that we are ready to go ahead to execute the assessment? So usually we will provide a list of expected documents from each stage, and we would normally say, if you have got all of these documents ready and approved, then we're good to go. But if most of the documents are not ready, then we suggest that you wait until they are ready. Then comes the expected list of documents relevant to each stage. And also we will have a short list of the roles of people that we probably will need to interview or have some brief discussions with. So those will be people like the engineering manager, the functional safety, the person who's responsible for overseeing functional safety, the chairman of the HAZOP study, for example, these kind of people. We will also indicate in the procedure when we find issues, how will they be handled? So how will we feed them back to the engineering team so that they can get resolved? And we'll also list out what deliverables we intend to provide from the FSA. And that can partly be down to what the client expects. So for example, if they want to have a management presentation, then that's fine, but we would like to be aware of that right at the beginning so we can prepare along those lines. So who can be the assessor for functional safety? Well, it can be done by a team. But the important thing is that at least the leader of the team needs to be experienced in functional safety overall and specifically in functional safety assessment. It's important to remember that this is a safety critical role because functional safety assessment is you could say it's the last chance to find errors or issues that have managed to slip through up to this point, either because the team wasn't aware of a requirement or because things got missed, especially in the heat of trying to meet deadlines and pressures and conflicting demands from all sides. Sometimes things slip through, and the assessor's job is to say, wait a minute, we really need to deal with this issue that we found. Let's not rush ahead until this is done. So yeah, it is a potentially safety critical role. Also, as I mentioned, there is an independence requirement, which in IEC 61511 simply says that there must be at least one senior person on the FSA team who's not otherwise involved in the project. IEC 61508, which is the overall standard covering all industries, has more specific tables detailing exactly how independent you have to be. For example, you have to come from a different team or a different department or a different office or even a different company. That is much more clearly defined in 61508 compared with 61511. So what kind of issues do we need to consider in the functional safety assessment? There are actually quite a lot of aspects that need to be covered, and our checklists have many hundreds of items that we will cover. But to give you an idea, and this is not a complete list, but to give you an idea of at least the main areas that we will look at, here are 9 areas that we will consider to be some of the most important. So the first one is functional safety management. So we want to see that you've got management procedures in place, that they are well written, that they are clear, that it's possible to follow them, that they are auditable, so they will actually generate evidence that they're being followed. Also, that the procedures include a planning requirement and that you've actually allocated the necessary resources. So, for example, you've actually, provided somebody and provided time and resources for somebody to complete important activities such as verification, competency assessment, and so on. So number 2 is the competency requirement that we've already mentioned. So we need to see evidence that competency is being managed, that you actually are doing checks to confirm that each person with a functional safety responsibility knows what their task is, knows what they're doing, knows what the outputs are, and also knows what can go wrong. If they don't really know what they're doing and they do make a mistake, what is the worst case outcome? We also need to see evidence for each key person. So we want to see usually some kind of checklist or some kind of assessment, maybe done by the personnel, whichever department is HR or whoever it may be, for confirming the competency of each individual. We have a standard competency management procedure with checklists that we can provide if you're not sure of how to go about that. So please contact us afterwards if you would like to see that. The third area is relating to management of change. So once the detailed design for the safety instrumented system has been established, at that point, you should enter a management of change regime in which any further changes need to be properly managed and reviewed to confirm what is their overall impact on the system. So we want to see that there is a procedure for management of change, and we want to see that if any changes have been made, the procedure is being followed. So there should be some kind of documentary evidence that we can confirm for that. The fourth area is the individual life cycle activities. So this means, for example, the HAZOP study, the SIL determination study, the preliminary design of the safety instrumented system, the SIL verification, and all of these steps one after the other. We would like to see evidence that each of these steps has actually been executed and completed. And a very good way to provide that evidence is by showing us number 5, which is verification. So as I already explained, verification is supposed to be a review of the output from each life cycle activity. So we would like to see that you have a plan to execute verification in a proper way that meets the requirements and expectations of the standard. And we would like to see that you're actually executing that plan. And preferably you're doing it in a timely manner. So as soon as each activity is completed, it should be verified immediately. What we sometimes find is that, especially sometimes engineering companies are not aware of the requirement for verification until somebody like an FSA assessor comes along and points it out to them. And then there's a scramble to try and catch up by doing verification on activities that were maybe completed a year earlier. And that really is missing the point of what verification is supposed to be. It's supposed to catch issues immediately, there and then, before they have the chance to propagate through the design. Number 6 relates to configuration management. So the idea of this is, again, at a certain point in the life cycle, you're supposed to freeze the configuration of each safety instrumented function in terms of, for example, the number and the design of the hardware that's used, the parameters such as the proof test interval, the proof test coverage, the designated lifetime for the equipment, and so forth. If the configuration needs to be changed at a later stage, then there needs to be proper management of that. Which could be included as part of the management of change activity, but needs to be clearly understood that configuration management must be in place and must be getting executed as required. Number 7 is document management. So similar to a quality management system, you have to have proper management of the documentation system, which includes things like making sure that documents are being properly reviewed and approved, making sure that everyone can confirm that they're using only the latest issue of each document, making sure that documents are properly structured with a clear title, with section numbering, written in a very clear way with no ambiguity, with no doubt about the meaning of each phrase and sentence within the document. In other words, keeping it clear, keeping it simple, and making sure that there are no holds or no TBCs to be confirmed or anything like that lingering in the documents. So it's really about making sure that the documentation is of good quality and it's being properly looked after. Number 8 is about action items. So any items that require follow-up from, for example, the HAZOP study, the SIL study, previous functional safety assessments, verification, or any other task that can generate action items, we would like to see evidence that you're closing those out. Now, typically, there will be an action items register, which we would like to see, and we'd like to see evidence that you are following that through and getting a proper closeout and proper approval for each action item on the list. Not that we expect every single item to be closed already, because we understand that's not always feasible at a particular stage in the life cycle. But we want to see that it's being properly managed, that progress is being made, that it's being taken seriously, and that it is being used as an effective way of achieving the necessary finalization of the design. Number 9 is management of contractors and suppliers. So I think it's well known in the industry that an unfortunately large number of incidents leading to injuries and damage and loss involve contractors. And so it's really very important, not just from the functional safety, but also from process safety point of view, to make sure that contractors are fully aware of the requirements for them to follow just the same levels of diligence and assurance relating to safety in general and functional safety as well, just the same as the employees of the engineering company and employees of the end user company. The standard has got some specific requirements relating to contractors. For example, they need to have a quality management system. The same goes for suppliers. So we would like to see evidence that contractors and suppliers are fully aware of and following the functional safety management systems that you have in place. So like I say, that is not a complete list of the issues, but that gives you some idea of the wide range of topics that we're covering here. And also, I hope it clarifies what I said earlier, that this is a high-level review. We are not digging down into the individual details, the individual engineering decisions that have been made. That is not the role of functional safety assessment. Now, I did mention a moment ago that verification and FSA go hand in hand. And if you have not completed a verification of each life cycle phase before going into functional safety assessment for those phases, then FSA is very much more difficult to achieve. And this is why I really wanted to stress at the beginning that it's important to complete all of these assurance or confirmation activities, not just leave it all to the functional safety assessment. If you do that, you will create a big headache for both the assessor and for yourselves. So just to clarify one more time, what's the difference between verification and FSA? Well, verification is focusing on the fine details that are expecting to come out of each life cycle phase, such as HAZOP or SIL assessment. And it asks the question, given the inputs and given the procedure, did we end up with the correct outcomes from that phase? So it really is looking down at fine details. Whereas the FSA asks, have I generated outcomes that I can use for the purpose that I need them for? So of course, in order to be usable, they have to be correct. That's one thing, but there are a great deal of other requirements as well, which FSA will also ask. But I think you can clearly see that if verification has not been properly completed, then it means that FSA will have to essentially do the job of verification, which is to do a very fine review of item by item from the outcomes to see whether it's really correct as well as being fit for purpose. And that's a much more difficult task, as well as much more time consuming for the assessor to complete. Plus, it's also really, as I said before, it's too late. Verification should be done immediately, not waiting a few months later when the FSA may come round. Now, let's talk a little bit about the checklists that we will typically use. So each assessor has got their own style, but this is the approach that we use. We divide up the checklist into 3 categories. So the first one is we're looking at each stage of the FSA. As we mentioned a few slides ago, there are 5 different stages. For example, stage 1 is looking at the hazard and risk assessment. Stage 2 is looking at the SRS, the safety requirement specification, and so on. So each stage has got specific requirements or expected outcomes from that stage and that stage only. So that will be our first checklist, is to look at the specific expectations for each stage. The second checklist focuses on each individual document, and the documents we're interested in are basically procedures and reports. For that purpose, we're treating a deliverable such as the safety requirement specification as a report, as a kind of an output document. So it's procedures and outputs such as reports and specifications. So each of those needs to go through a checklist that looks at various aspects of whether the document has been verified and whether it complies with the documentation requirements and expectations. So we go through that checklist for each document one by one. And then the third checklist is specific to the SRS, which is the safety requirement specification. The reason that we have a separate checklist for this is because it's usually very large and very complex document with a huge amount of data in it. And we want to confirm that the SRS is complete and that it is basically fit for use. We are not going to check the correctness of every single item of data. That should be already done as a verification activity. But what we are going to say is answer the question, is this SRS fit for the purpose for which it is intended? And that's a pretty large task. So that's why we pull that out into a separate checklist. Also, the SRS is normally prepared at 2 different phases in the life cycle. So usually immediately after completing the HAZOP and SIL studies, you will prepare a preliminary SRS, which is the initial data about the basic design of the individual safety functions, which then allows you to go forward and do the SIL verification and the move on into the detailed design. And then you prepare a second phase of SRS, which is where it contains all of the requirements as listed in the standard, not just a small number of them, as it was for the preliminary SRS. So normally we will assess the preliminary SRS at FSA stage 2, with only looking at maybe 5 to 10 out of all the 29 requirements for the SRS that are listed in the standard. And then when we come to FSA stage 3, we will then review the entire SRS and check all 29 requirements. Let me show you some examples of the questions that we have in our management checklist. So this is where I said this is where we're looking at the expectations from each life cycle phase. So for example, we will ask, have the functional safety tasks for this stage been completed? So tasks like, have you executed a HAZOP study? Have you executed a SIL study? And so on. Did you meet the specific requirements? So if there are requirements that are listed in the standard for this stage, for those phases, have those specific requirements been achieved? Now, hopefully that will be shown up in the verification, because the verification should be asking that question. So we should be able to just simply check the verification report and see that the answer is yes immediately. Unfortunately, that is rarely the case, and usually in practice we have to check by ourselves one by one. If the tasks executed so far have generated action items, then we would like to see that those action items have been put in a register of some kind and that they're getting closed out, and there's evidence of closeout and sign off for those. We would like to see that you have some kind of responsibility matrix, or a list at least of who is assigned to each significant task relating to functional safety. Then for those key individuals, we'd like to see that a competency assessment has been done for those. We would like to see that you've executed verification for the relevant life cycle phases that are already completed. We would like to see your functional safety management plan. The plan does not need to be complete right from day one. It can kind of grow as you work your way through the life cycle, but at least we would like to see that the parts of it that need to be in place up to the stage that we're now reviewing are fully completed and approved and getting implemented, and that you have your plan in place ready for the next phase of the life cycle. We also want to see, does the plan actually seem to be good enough? Is it detailed enough? Is it clear enough? And is it auditable? Then a next issue we'll look at is your contractor and supplier management, to confirm that you've got control over both the selection of contractors and suppliers, and also the management, to make sure that they're receiving the data that they need, that they're aware of what the functional safety requirements are. And then the next one is management of change. So if you've reached the stage in the life cycle where management of change needs to be implemented, which for me would be from FSA stage 2 onwards, then we'd like to see that there's evidence that that is in place. That was checklist number 1. Now, checklist number 2 relates to individual documents. So we would like to see that the documents we would typically expect to exist actually do exist, and that they've been properly reviewed and approved. So again, that can be part of the verification if that's been done. We would like to confirm that you have a document management system in place and it's working. We would like to see that the documents themselves are of good quality, by which we mean that they are clear, that they're precise, that they don't contain contradictions, that they're well laid out, well organized, basically so that people can actually use them for the purpose that they're intended. There are a few specific requirements in the standard. For example, IEC 61511, Part 1, Clause 19, lists some generally not too difficult to achieve requirements relating to the standards. Relating to the documents, we would like to confirm that those specific requirements are met. And one of them in particular is we would like to confirm traceability. Now, this can be one of the most difficult things to achieve in your documents, especially if you don't have traceability in mind right from the beginning when you first design the way the documents are organized and laid out. But the standard does have very specific requirements that all of the data in outputs from safety lifecycle activities needs to be traceable back to its source. So we would like to see that you're achieving that. Not that we're going to check every single link back to the source, but at least we would like to see that you're making the effort, and we probably would check a random sample of them. We would also like to see that the documents are suitable for use in verification and also for when it comes to functional safety audit, that the documents, for example, generate an evidence trail that can be used by an auditor at a later stage. So that's the documentation checklist. And then the third checklist that we talked about is the safety requirement specification checklist. As I mentioned, the SRS is typically developed in 2 phases. The first phase being at stage 2, which is an initial or preliminary SRS containing just a few basic bits of information. But then by the time you get to FSA stage 3, the complete SRS needs to be developed. So we have basically 2 separate checklists, one for stage 2 and one for stage 3. By the time we get to stage 3, we want to see that all of the 29 requirements of the standard have been implemented in the SRS, and that the information that's given at least seems to be in a reasonable form. We are not going to check every single item of data to confirm that it's correct. Again, that should be the job of verification. But at least it needs to look like you're on the right track, that you've understood what the requirements are, and that you've written an SRS that is suitable for purpose. Now, so far, we've only talked about the hardware SRS, that is the SRS that defines the requirements for the SIS hardware. But there is also a requirement for a software SRS, which is sometimes referred to as a functional analysis document. And this document is quite often prepared by the system integrator or by the vendor of the logic solver that's been used in the SIS. So that we also need to see and to confirm that it's meeting the requirements of the standard. We would like to see that the SRS, both hardware and software, have been verified. Okay, I see a question coming in. Can you tell us about the software SRS? Is it required if you already have an SRS and just adding a single function? So the software SRS, I think probably the clearest way I can answer that question is by showing you what it says in the standard. So if you can bear with me for one moment, I'm going to open up the standard. This will just take me a moment or two. Just go to that, to the standard. Okay, should be coming up. Here we go. Okay, I'm going to go to clause, I believe it's clause 10.3.3. Let's see if my memory has not failed me on this point. So this is IEC 61511, the latest edition, 2016. Here is clause 10.3.3. Just make it as big as I can to make it easier to read on your side. So it says here the application program safety requirements, meaning that you have to produce some kind of specification, shall be derived from the SRS, by which it means what I call the hardware SRS. The application program safety requirements may be located in the SRS, so could be all as one integrated document, or in a separate document, which is what I just called the software SRS. And here it says application program requirement specification. And then it gives you a big, huge list of specific requirements. So for example, here in section 10.3.5, it says what you need to actually write into the software SRS. For example, the second bullet says things like real-time performance parameters, CPU capability, network bandwidth, programming sequencing, equipment and operator interfaces. What else? Action to be taken on bad process variable, functions enabling proof testing and diagnostics. So that would be things like if you need to have overrides, forces written into the software, self-monitoring, for example, watchdogs for the application software, and monitoring of other devices, of hardware devices. So that will be, for example, if you've got smart transmitters with built-in diagnostics, then when those smart transmitters send a message to the logic solver saying, help, I've got a problem, then the logic solver needs to know what to do with that. So that the specification for what to do and what information to expect from the smart transmitter also needs to be defined in the software SRS. So typically that, okay, so Joe asking, in my experience, is this usually written at system level rather than individual CIF? I think the answer is yes. I would not generally see the need. Well, okay, most of the requirements, I think you can say they would be at system level because they're going to be pretty much the same for each individual CIF, but there may be some specific requirements. So usually you will have what you might call a functional analysis, which is a kind of some kind of logic diagram, maybe, where you map out in a way what the ladder logic is going to be using some kind of logic blocks. And at that point, that's where you would show things like overrides and resets and voting logic and things like the last point that we just mentioned about detection of failures of the transmitters, so that basically it's absolutely clear to the person who actually has to write the ladder logic code exactly what the requirements and what the expectations are. And that will vary from one CIF to another. So that you do have to do at an individual CIF level. I have to admit that this is just on the kind of the edge of my limit of my expertise. So I probably can't say too much more than that because I don't actually know much more than that. But the people to talk to about this would be the people at the CIS hardware manufacturers, people like Yokogawa and Emerson and Invensys. Those are the people who really understand this stuff, and Siemens. So I hope that was helpful. Let me I will not overshoot the time. Okay, we have another question. What can go wrong when the system? I'm sorry, I don't quite understand the question. What can go wrong even the system determines the SOC? Can you clarify the question? I don't quite understand it. I'm sorry. Do you mean what kind of what kind of system faults do you need to describe in the software SRS? Is that the question? You can feel free to turn on your mic if you want to ask. But yes, so that was the question. Okay, that I have to say is really outside my expertise, and I would rather not even attempt to answer that question. I'm fear if I do, I will only share my ignorance and not my knowledge. I'm sorry about that. That's definitely beyond what I can be helpful with.
No, my question, the question or the rather statement was that because when we use the hardware and then write the software, then we also know what the hardware, what situation we can land up in various kind of faults with the hardware.
Okay.
And then accordingly we make our software and hardware so that we can do justice to our SRS.
Okay, so are we talking about failure modes then?
Yeah, yes.
Okay, right. Okay, I see what you mean.
We have to visualize the kind of failures that what can happen, that will determine our SRS. Yeah.
I do. Right, now I see what you mean. That is actually quite a big topic, and somewhat a little bit off the topic of today's webinar. Maybe why don't we have a discussion about that offline? If you'd like to just drop us an email afterwards, and we can discuss that a little bit afterwards.
Okay, thank you.
Yeah, sure. Thank you. Very, very interesting question, though. Yeah. Okay. Well, I'm almost done with what I was planning to say. I just wanted to say a little bit about interviews, because I mentioned that one of the ways in which we may collect the data for the FSA is about by means of having some usually online or telephone interviews with a small number of key personnel. And just to clarify, what's the purpose of this? It's not meant to be trying to put people on the spot or find flaws or find weaknesses. We're really just wanting to confirm, I would say, three things. First of all, that what they wrote in their competency assessment is really true. So, for example, if they said they've got experience of this project and that project, we will just ask a couple of questions. Tell me something about what you did in that project, just so that we can validate what they wrote. Second point would be to make sure that they're aware of what functional safety is and what their responsibility within the life cycle is. The reason for asking this question is we very often find the case where the functional safety management plan is just a huge document gathering dust on a shelf. And it says person X is responsible for task Y, but person X doesn't even know that because they've never been informed. So we want to make sure they've actually been properly informed, and they have the knowledge, they have the training, and they have the resources to execute those responsibilities. And then we also want to know that they know what procedures to follow. They know what procedures exist, what the relevant documents are, and how to access them, and what they're expected to actually do with those procedures. Now, if this sounds a little bit like a quality assurance audit under an ISO 9001 quality management regime, that should not be a surprise, because really we're asking very similar questions to what a quality auditor might be asking as well. Okay, the rest of it I think is fairly obvious, and I probably don't need to say much. One thing is, when we do find issues, we will try to get them closed out informally first before going to a report, because we want to leave as small a number, the smallest number of open issues as possible. And many of the issues that we find may simply because we didn't see the right documents or there was a misunderstanding about what we wanted. We will also try to assess the criticality of each issue, so that we don't basically cry wolf and say, oh, this is absolutely terrible, you must stop work, when it's just something like a small issue like a document number is incorrect. So we will try to be reasonable about the criticality of the issues that we find. Okay, that's all I would like to say for today. I hope it was helpful for you. Please do feel free to ask any further questions now, or you can always get in touch with me afterwards. My email address is on the screen. Also, if you found today's webinar helpful and you would like more specific training on FSA or on any other topic relating to functional safety, we do have training packages available. We can offer self-study packages, which you basically go through like distance learning at your own pace with the support of a tutor. Or we can offer kind of online classroom training as well. Given that many of us are still struggling with the COVID situation, we'll be very happy to organize that for you. And we also have a newly released functional safety exam study guide. So if you're planning to prepare for a functional safety exam, such as CFSE exam or TUVFS, then you might find it helpful to get hold of our book, which contains a whole lot of example questions, exam questions with answers and explanations. So if any of that is of interest, please contact us afterwards, but I will now turn it over to any questions that you may have. So please go ahead with your questions. Thank you very much to everybody. If anyone has a question, please feel free to ask or get in touch afterwards. Okay, so no questions coming through for now, so I'll close the webinar for now. We will be posting a recording later on YouTube, so you can catch up later if you missed any of it or want to go through all of that excitement one more time. But for now, for today, thank you so much for your time. We really appreciate it and wish you every success.